All right, so we are talking about psi. And then we're talking about the sine of angle A. So this is, technically, it's sine of angle A. It's abbreviated SIN and then the capital letter A. We circled A up here, and we circled it on our triangle so you can see we're talking about this A right there. The sine of angle A is the side that is opposite A. So here we have side opposite A, and we have this little blue A that matches up with this little blue A. I think of it like opposite means across. It doesn't come in contact with A at all. So this side, this blue line, does not come into contact with angle A at all. It's as opposite from A as you can possibly get. So that's why it's called the opposite side. And it's the denominator, the bottom of our fraction. So our sine of angle A is just a fraction. All it is equal to a fraction. That fraction is whatever the opposite side of angle A is divided by the hypotenuse of your triangle, which is right here. So we put together a little fraction. It's our opposite side over our hypotenuse. That is what the sine of A is. So when you hear sine A, your brain needs to automatically go fraction. Two pieces of a fraction, the top piece and the bottom piece. And that's what the sine is. There's three operations that we use for trigonometry because how many sides of a triangle are there?
Three.
So 3 sides of a triangle, 3 trigonometry operations. So the second trigonometry fraction that we put together is called a cosine. So it's a cosine. Cosine.
Do I have to write the word written out?
If you want to write cosine,
okay,
which is how it's not abbreviated, we abbreviate it as COS, and we usually say cosine. So cosine of angle A. So once again, we're talking about angle A. That's this guy right here on our triangle. The cosine does not use the opposite side at all. It uses the adjacent side, which matches up with, so think about this, if you're adjacent, so imagine you're sitting real tight, like in the school bleachers, like at an assembly. If you're directly adjacent to somebody, you're kind of probably touching elbows or touching kneecaps with those folks. So adjacent means next to. So we have, when you look at next to's, well, this guy is next to A, it touches him, and this guy is next to A, it touches him. So which one is the real adjacent? With the real adjacent, please stand up. Please stand up. Please stand up. It's the one that's not the hypotenuse. We already know that this is the hypotenuse, so it does not get to be the adjacent.
I think so. Okay.
The hypotenuse is the king, and once you get called the hypotenuse, there's no way you can be anything other than hypotenuse. Hypotenuse is always a hypotenuse, and nobody else can be, you can't be anything else. So when we're talking about the side that's adjacent to A, we want to talk about the side that runs right into angle A. And that's side B. So the fraction we're going to put together for the cosine is, we're going to put side B, whatever distance or length side B is, on the top. And then we're going to put the hypotenuse on the bottom. So we're going to create a fraction. There is only one other option we can do, and this option is called the tangent.
Oh, I remember Sohcahtoa.
All right, so we have the tangent of angle A. So here's our angle A again. And the tangent is a fraction made up of two parts. The first part is the opposite side of angle A. So once again, we're dealing with little a. So we find that distance. And the side that's adjacent to A. That's this guy right here. So trigonometry, all we're doing is we're putting together fractions using the triangle side lengths. Sine of angle A is opposite over hypotenuse. Cosine of angle A, adjacent over hypotenuse. And tangent of angle A is the fraction opposite over adjacent. There's only three possibilities that we can use because we only have three sides of our triangle. Okay. All right, Sohcahtoa. On a Polynesian island, there was a tribe of indigenous people, and they would pray to their god, and it would sound like this. Sohcahtoa, Sohcahtoa, Sohcahtoa. Because everybody knows.
I don't know, dude. I think Sohcahtoa is cooler than.
Sohcahtoa does not know trigonometry.
She knows
sure knew her way around.
Are you sure? She knew her way around the.
She knew her way around the Pacific Northwest, but maybe not so much.
Corn stuff.
Okay, so you guys, let me tell you, we use Sohcahtoa as a memory tool. So, SOH stands for sine opposite over hypotenuse. Ka, it's my bird one, is cosine equals adjacent over hypotenuse. And toa is tan equals opposite over adjacent. So Sohcahtoa is just a way to remember sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, and tan is opposite over adjacent. I told that story to you. My geometry teacher told that story to me. Thank you, Mr. Galloway. And now you guys are hearing it. So circle of math goes
And then
on.
I will be doing it.
And you guys will tell your children when you tutor them in their
That's what I'm gonna
trigonometry,
teach.
you will tell them about Sohcahtoa. You will sing them the Indian chant because sometimes when it's late at night, you will do anything to get them finished with their homework so that you can get them to bed and you don't have to deal and hear their voices anymore.
I know, dude.
Oh, it happens.
No, it doesn't.
Okay. So you guys, let me show you in example 1 how this rolls out and how we can... Shh. Jose. Let me show you how this rolls out and how we can switch our perspectives. So think about this. We're going to switch perspectives. So we're going to hop from angle S. We're going to find all of our three sine, cosine, and tan for S. And then we're going to hop off of S and onto R, like we're a little flea. And we're going to find all of our perspectives. So let's just, for fun, let's go ahead and put the flea. Let's go ahead and put your little trigonometry flea. He escaped the erupting volcano of Sohcahtoa. And we're going to put our little flea on S. If you guys have never drawn a flea before, it's a little oval. And give him little antlers, antenna.
It looks like a piece of candy.
Okay.
S. So
he's got his little antenna, his little flea antenna, and he's got two little legs. I don't know why he's got two legs. I know that's wrong, but. So we're going to put our flea on S. S is the perspective that we're looking at this triangle from. So we're going to label the hypotenuse, because he's the king. He stays the hypotenuse no matter where my little flea hops. He is always going to be the hypotenuse. The hypotenuse is always the king. He always stays hypotenuse.
What do you do in the bottom corner?
The flea.
Oh, that's the flea?
Yeah. We put our flea on angle S.
Well.
Where's Anthony Keel this guy? That is an awkward looking flea.
That looks like a lady flea.
He gave it away, so he gave away his flea. So.
The slug of death.
Wait, did he leave?
The slug of deathness.
Okay, good. It's been a while since I
Okay. So the side that is opposite our flea, so it's the side that doesn't even touch our flea, is over here.
Oh.
The side that is adjacent to our flea, it runs right into our flea and is not the hypotenuse, is right here.
So
We have a
5
little
over 13.
dilemma on my paper. There is no opposite side.
It's 5 for us.
Is it written on your
Yeah,
paper?
it's written as 5.
Good, okay. It is a Pythagorean triple, so I was going to have you look it up, but I will just write it
Wait,
here.
does that mean it's 5 over 13?
If you did not know one of your sides, you can use Pythagorean Theorem to find it. And we will probably have to do that in your near future. So you will probably have to use Pythagorean Theorem first, find your missing side, then put your fractions together. All right, so we have 3 fractions. We have our sine fraction, our cosine fraction, and our tan fraction. So the sine of angle S, the sine of angle S is the opposite over the hypotenuse. It's all we're doing is we're putting together a fraction. So the opposite is 5, and the hypotenuse is 13, and we're done.
That's it?
That's it. That's trigonometry. It's just writing down a fraction. Cosine is the adjacent over the hypotenuse. Adjacent is 12. The hypotenuse is 13, and we are done finding the cosine of angle S.
Oh my God.
Just write down the fraction. That's all we're doing. The tangent of angle S is the opposite over the adjacent.
Why do I only have 8?
And that's all we're doing. And we're done with this, with example A. Example B, we have to move our flea. We got to move our little flea. We want to put him on angle R. So we're going to take our flea. If you have to erase him, go ahead and, oh, he's got one antenna. The other antenna. His leg.
1 by 1.
We are dismembering our poor little flea.
I like that.
No, baby, come back.
All right, now our little flea is on R. Hypotenuse is the king. He stays the same. But which side is opposite our flea now that he's on R? Boop, this guy over here. So this becomes the new opposite. Oh man, our flea moved, so our opposite also moved.
So whatever corner it's in, the one directly across is the opposite, and the one next to the adjacent.
Yes, correct. And the hypotenuse stays the same. Good assessment. So our new opposite is 12. Our new adjacent is 5. We're going to put together sine, cosine, and tangent for our new perspectives. So the sine of R is the opposite side over the hypotenuse. Opposite side is 12. Hypotenuse is 13.
So it's kind of just like the reverse of what we did.
Cosine of R is the adjacent, the new adjacent over the hypotenuse. New adjacent is 5. Hypotenuse is 13. And the tangent of R is opposite over adjacent. The new opposite was 12, and the adjacent is 2.
He's actually from there. Interesting.
That's his heart.